Okay, here we are in our last video for site suitability. The first video we looked at the type of data, the type of criteria we wanted to include, and we looked at thinking about starting to rank that criteria and how to rank that criteria. In the second video we did that ranking, we did the reclassifying steps that you're seeing here, and now we are moving to our last output where we are going to rank between the different data sets. So before we were ranking within, so we would classify distance from electric vehicle charging stations. We were classified median income. With the new classification, we were classified land use. Looks like we have to run the reclassify tool for the roads again because it doesn't have the shadow behind it. So we're going to see how this doesn't have that drop shadow. It's telling me it's not actually there, so we're just going to rerun that real fast, and it shouldn't take too long because it's the Euclidean distance for roads. But while that's running, we can pull over our criteria table again. So we have already reclassified our 4 data sets in these columns. So up and down or across the rows for each data set, we've ranked how important each criteria was. And in this example, unlike the class example, we switched these two around. Switch the highest or the most suitable category in the medium suitability category around. Okay, so now our question here is the assigned weight. And based on what we talked about in class, we had some discussions about how to weight these things, these different categories. Did we ever come down on the definition? Oh, we did, but I didn't write it down. Oh, no, here we go. Oh, I know where it is. Hang on. Okay, so we'll see the math for this type suitability. That was my original thing, my original idea, that close proximity to roads and EV charging stations would be the most important, income would be second, and the land use would be first, or least important. So 3 is the most important, 1 is the least important rank. And then we can add in, when we talked about it in class, it was suggested to reorder the ranking. So the most important criteria would be proximity to the charging station, followed by land use and roads, lastly, the median income. And in that article that I have up on Canvas, it talks about how to go about creating these data sets. You can see, let me think about that. Actually, I wrote the formula down at the bottom of the slide, but the relative weight for each layer is equal to 100 divided by the product of the sum of all rankings times the ranking for that layer. So let's go back to our sheet. So we see the, this should be 100 divided by this one, not 9. It was 9 before, it's 8 now. I'll put in B7 so we know what we're doing that. So let's see, let me make sure 100 divided by B7. Yeah, so it's 100 divided by this sum of all the rankings. So 2 plus 3 plus 1 equals 8. And then it is multiplied by the ranking for that layer. So we can see the formula here, 100 divided by B7, or the 8 value, and then we multiply it by that assigned rank. So our multiplier for major roads and land use is 0.25, 0.375 for proximity charging station, and median income is 0.11. So that comes into play. I'm going to have it on my other screen, but let me close this. Comes into play in our raster calculator. The raster calculator is where we're taking our 4 individual rasters, each representing a different attribute: land use, median income, distance from roads, distance from other electric vehicle charging stations, and where we're adding or doing that matrix algebra to create our final suitability analysis. So we can see here, I didn't have time to do it in class. Let me drag this out so you can see it all in one row. Here what we're doing is we're asking it, as it lays each individual raster data set on top of each other, that it adds the values for each cell together. And it's each cell for each criteria. So for median income, we're telling it to multiply the value in the cell times 0.25 and add it to the row distance one, so it's the value in the distance times 0.25, et cetera, going forward. Go ahead from here and click OK. And we have to hit run. And this may take a minute or two, so we'll see. I need to pause. Okay, so our analysis is done. We can see that the drop shadow on both the tool and the results. So if we go ahead and go to add to display, over to our reclassify window, and let's group this into our categories. We can start to see that we're seeing the values, higher values are in white, so the more suitable layers are, or suitable areas are in white. So I'm going to go ahead and start by inverting that. And so I used green before. What's a good contrast from green? Oh, I guess we can keep it green, and then you can see the change between the two. They're slightly different greens anyway. So then I'm going to invert this. So yeah, so the higher values could also, if you wanted to, that's not what we wanted to do. Or we should go ahead and change it. So right now we can see we have different values for our sort of 5 classes. We could go down to 4 if we wanted. And probably, I mentioned this in class, but probably if I was presenting this to the public, I would change these labels since the values don't matter to the general public. Well, let's say high suitability. What were other classes? High suitability. Medium suitability. Low. Just click low and least. Okay, and you can fix that later, but this is sort of an easier way to maybe think about what your results are actually showing. So I definitely, well, in many instances, I don't know if I'd recommend keeping the raw numbers up there. Okay, so we can see this is our in-class result when we change that income value. So originally we had the lowest income be the highest suitability or most significant. So here we can see we switched that, and this is our original data. And it seems to, the impact it seems to be having, and again, we're in slightly different colors. I guess I could change. Oh, and I took out a class. Oh, that's what I should do on this one. Hang on. Okay, so we can see our values have changed a little bit, but we're going to start to see, you know, it doesn't have a lot of impact on some of the most suitable locations, which again, we're all kind of like, what, way out here. You can see these are really strongly influenced by the distance to the roads, so that's something that maybe we could think about reweighting roads. Because this is our in-class result. You see some of those places being taken away by changing that income factor around. But it doesn't, I mean, it didn't really clear up the things that we had issues with our original results, mainly, or I had issues with, mainly with Camp Pendleton coming up as most suitable when it's not exactly a public location. But that's part of, like, this goes back to the land use classification. Anyway, so that's part of a suitability analysis, is getting your results, thinking about them, and then going back and redoing it. So since we did change the income, you'll see some places go from least suitable and move into the low suitability. So I'm curious as to why that happened. But I don't know. What do you guys think about the results, how they've changed? Suitability is something that we use a lot. Suitability is something that there's a lot of back and forth. So make sure you save your model. But a lot of back and forth, a lot of iterations, a lot of trying things. So your first draft is usually just that, a first draft, and then you'll go back and revisit and adjust. So not the end of the road for our electric vehicle site suitability analysis, charging station suitability analysis, but a good start.